So we're recording. This is not Cliff Click. Standing in for Cliff. It's Friday, the 25th of August. Coffee Compiler Club. Cliff is in, he's at Raining Man this week and next week, I think. All right. So don't see anyone new. So welcome, everybody. Some good conversations going on this week on all sorts of stuff. So we'll see how many of them carry over to the call. Anyone have some topics they want to discuss this week?
Wait, no, we should start. He always reads like the spiel at the beginning of the talk. He's like, this is Coffee Compiler Club. My goal is to have a conversation about compilers. I don't remember what he
You're
said.
doing great. Keep going.
Okay. My goal is to have a conversation about compilers and language implementation, code gen, optimizations, implementations, GC, runtime support, locking, concurrency, and libraries are all fair game. I don't know who's moderating. Probably Cameron, you, but
I
um,
reserve the right to moderate. I never
yes,
had,
And
but I've never
never
had.
had to do it.
yes. Okay,
You
all
are being
right,
recorded. This will appear on YouTube whenever Cameron gets to
Hey, we're good at this. All right.
all right, okay. Yeah, I mean that's not what he actually says, but it's close enough. All right, into topics.
So that'll be our intro. Where's Tito when we need him? So anyone have some something on their front burner this week?
Yeah, I was thinking about macros versus generating code ahead of time. That I both see the pattern regularly where someone's like, oh, I'm going to write this YAML file that describes my API, and then I'm going to generate a whole bunch of code that does that. And I've seen patterns that are like, oh, I have a macro that takes a short object that describes what it should be and does the more complicated thing.
Hmm.
And when is one of these more appropriate than the other? It feels weird to check in code that a computer wrote, but also it can be difficult to debug the macros because I can't see what's happening because it's running code that never actually got printed out.
It depends on the sophistication of the generator, whether you get free docs, free API testing, etc., from your generator, or if you're just generating a shell script or from a shell script.
So I
So
think
See, I
that is
was
fair, but also sounds like a challenge. It's like, well, why are our macro systems not strong enough that our macros can generate the doc?
Well, like speaking from experience with Swagger, it's a good thing until the back end of those tools, overrun the intent. Like in Java, you can barely get it done because it got so complex they stopped maintaining it like 3 years ago. Um, but it works for JS. JS just generates it on the fly, whereas precompiled languages, have a little bit more work to do. But in terms of documentation, it's pretty awesome. You get a predictable API layout from the YAML if you have to go that way. So if you go with the JSON version of Swagger, there's a what is it, JSON schema online tool that can really take apart someone's random JSON, and that helps a lot with Swagger. So it's not exactly to answer your question. It's very biased towards Swagger, but that's a great example.
Hmm.
So if you're in a language that has macros, would you want there to be a folder that's just like, here is the waste byproduct of having used macros? That's the file where I dump the code and then I can run auto document generation on the code that was generated by the macros.
There's a big red button in the Java community called the Lombok debate. Um, and,
I'm not
and
familiar with this term.
It's
Lombok
a
is
library.
half of what you said.
Okay.
So, it removes pieces of Java. Before Kotlin existed, Lombok was sort of doing things a little bit simpler than all of the inversion stuff. What do you call it? Inversion of control stuff, which was a total mess. And
I mean, dependency
so,
injection.
yeah, dependency injection and inversion of control. So, uh, you know, it kind of points out, well, Java's too verbose, and you can write Java simpler and we'll generate the parts that no one wants to write. Um, but, with a framework that, intends on self-doc, I think that's the stronger point, is maintaining documentation uh, is managed slightly better if there's a schema that corresponds to the code as it's generated.
Yeah, and there's also kind of two major families of macros, which we could probably split as Lisp macros versus C macros, right? So you have C macros, which are basically pure expansion of text, and
Yeah,
Lisp
they're
macros,
basically string to string.
right?
Yeah,
So,
but also,
But the
go,
list is untyped. Lisp macros is dynamically typed.
I mean,
Correct?
yeah, they're also like staged compilation. So something like Zig has like something that technically looks like macros, but it has like type information. So it's probably, you could say, in some ways a bit stronger than Lisp, but there are also other like staged programming, like multi-stage programming approaches that are like even stronger. And also for the code generation versus macro thing, I think keeping things in a language without introducing like a stratification between language and then yet another configuration language is a good thing. And I really don't like having many ways of doing some kind of like code configuration. But I can definitely see the use case for something like a code gen tool that doesn't like that just is like an external thing and it's not based on macros. If the code gen tool needs to be compatible across lots of languages, so something like Protobuf, I can see why you would want to have a tool for that, because not every language has macros, so you can't implement the schema or like generate it for everything. So if you want to have like compatibility across multiple code bases, like this is probably a good use case for it.
I was about to
Yeah,
say the
although you
same
don't
thing,
have
that Protobuf is like the perfect example to turn the question around. How would you optimally define Protobuf across several target
I
languages?
I think it's the other way around. The other languages they fold into the semantics of the target language. That is sort of like ideal. You have limited number of constructs that all of the languages need to boil down to, need to compile to. So in Protobuf, it's like a few constructs, like you have to be able to translate to some kind of class, a struct, and pretty limited. It's a language with pretty limited constructs, and every other language needs to boil down or compile to this simpler language. It's the other way around, at least to me.
yeah, and then there are
But it would still be
languages.
awkward to have a function that's just like the body of your function is protobuf syntax, and you've got a macro that changes that. Like
No. You don't
that would
need
be
to
super
support.
awkward.
You don't need to support. You need the construct of your language to compile to. You don't need to bring the protobuf language in your language. You need to. That's how you translate to protobuf for loops. That's how you translate to C struct equals protobuf class. So you need to equalize the construct in order to compile to this language. And this
How do
language
you get
deals with.
round trip Proto by assuming your language knows it?
You generate code, you generate serialized deserialized code in your language. That's the target. It's the target construct it supports, the protobuf or thrift or any other. It supports serialization and then serialization, be it however you choose to support it,
Right,
because
but
there
I
are
tend to want
multiple.
that code generation to run before typing time.
Okay,
That
so
kind
I
of,
was
yeah.
I was thinking about this problem as well. So I wanted to serialize my data, and I didn't want to do templates like C++ templates, which I implemented, and then like a long time ago, and then just did not like because it ended up being like C++ templates. I thought about doing compile time things like Zig does, but I didn't want to slow down the compile time, and it also
It is
I'm not sure how
necessary
easy it is to debug.
in this concept. It is necessary to distinguish, to separate the code generation from the generics. So in templates, they are kind of both.
Yeah. So I end up wondering, what do you guys think about putting all your definitions that you want to serialize into a single file, and then having your build script just generate your code for you instead of having it in the language?
That's kind of a use case a macros would support. So it's ideal for this because
No, I don't know anyone that likes programming with macros.
Mhm. Mhm.
Especially C macros, but C macros can't do
C
this.
macros
Search
are
the word
kind of
bracket
macros.
and read what you get. You'll find some people who like programming with macros.
Yeah.
Yeah, but Racket's more in the Lisp side of the macro family. So it's a
C style macros are particular flavor of macros. It's
yeah.
not the concept of macros itself.
But
The only thing I was
but I
wondering
couldn't
is,
use C without macros. Like C
Yeah.
without macros is dead. Like
Mhm.
yeah,
So
And
it's a way
without
to
C macros,
explain
we
that.
wouldn't have IOCCC. So that would be
So
a pity.
Aaron, can you quantify the technical debt of going uh, with straight code, templates, and code generation? Templates being
yeah,
macros.
yeah,
did he lock up?
yeah. We don't hear
Interesting the
you.
way in which things. Do I not have audio?
Aaron, you're
You're
choppy.
back
Start
now.
from the beginning. Start from the answer from the beginning.
He went into GC.
We've just found that very different patterns work for different things. That there are some places where we were using build.rs to run before and generate a bunch of code. And that ended up being a pain because there was all this noise in the diffs and like things you didn't want to review because that code was just not code anyone ever wanted to look at and felt like it should just be in the target of some build. And then you have things like the open API where generating docs and generating the HTTP server that you usually did want to check in and be able to read and have your editor click at it and take you to the generated code so you could see what was happening. And it was just interesting to me that it feels like a language both needs these macros that just expand things silently on you because you don't want to see the expanded code because that will make your eyes bleed. You want to look at the nice compact representation. And at the same time, I find that there's stuff like the generated HTTP server where I really want to be able to dive into it. And it feels like a gap in languages. I was like, these two concepts seem like something that should be able to be joined and let the developer do what they want as they want it, instead of needing to a priori make a decision of, is this a thing I'm doing with a priori code generation, or is this a thing I'm doing with a macro?
Yeah, and
Like,
it
is there
comes
a way to
down
unify these
to
two concepts? And I couldn't come up with anything better than just have both concepts.
I also have the concept of folding complexity, which is kind of what you were saying, Aaron, except that there's a period of time or some subset of developers or some combination thereof where they want to treat the expanded form as something that they can step through in a debugger and see the documentation for and so on. And then there's another time where you want to be able to fold it in on itself so you never see it. Kind of like what IntelliJ does with curly brace blocks. You can kind of plus and minus them.
Yeah, that's true. My debugger has a separate concept of step into and step over.
Right.
I kind of want step into and step over with the ways in which I'm looking at something. First, show me the template that was used to generate the code, and then let me step into it if I care.
You want a collapsible build process, kind of like the collapsible brackets.
I like to end a handoff with something that is compatible with Doxygen, not for actual documentation, but for the SVG clickable object hierarchy and the other taxonomies it produces.
Maybe the answer is really generate that stuff, but let it live in the target directory that get ignored.
Yeah, so that's what I was thinking about my build scripts, but I was thinking that maybe people don't want to parse how I laid out the structure in my language, and maybe I should output JSON, which would defeat the point of using it for JSON. But yeah, if you could just um, if you can ask the compiler to export a certain file as a JSON, and then generate um, like the deserializer and the serializer at build time only when the file changed. Uh, I was like wondering if that would be like the best solution, but I don't know. You said that you wanted macros a lot of the time, so I'm not sure.
I, there are times that for this particular case, but at least to me, is the optimal. You generate the serialized and deserialized code at compile time, so you don't really care how it's serialized and deserialized in this case. But other times you need
So
to
what
dive in the specifics.
so what recent high-level languages have macros? Scala doesn't have macros, correct?
It has, and
Oh, it
Scala 3
does.
has even more powerful macros. The
I've
problem with
never used
macros,
macros in Scala.
the macros are the most powerful things. At some of the most powerful things in the language, it can pretty much generate any kind. The Scala 2 macros were more complicated because the API was kind of unrestricted. You can generate anything you want. There was def macros, which is expand at compile time, but the problem was that the macros leaked too much of the Scala compiler internal APIs and was unstable to support. So Scala 3 macros are a clean slate re-implementation of macros, which have an API which is independent from the compiler internals. So it has macros, and it's the only style of macros I pretty much like. It's the quote macros or something with that. You insert the quote and you write Scala as you write any other code. There is no API difference. It's just the Scala code. So the interesting thing there was even though it's a macros, it's a kind of higher kind of type. You need to tell it what type it will produce. So in the end, it will produce a string, a class. You need to set up the target type. So in order to remain stable, if you will, that's a kind of style of macros I like. So it's not unrestricted. The type has to be known as at the macro definition, if you will.
What do you think, Adrian?
I'm just looking through this picture there that was sent in the chat. It's pretty cool. But yeah, so like you mentioned, so Scala 3 has now a bit more stable macros. They're independent of the compiler. I see.
Yeah.
Cool.
Yeah.
So is it also syntactic, like, or do you like manipulate AST tokens, or like how does it work?
It has a set of API, if you will, that is not it's independent representation from the compiler internals. That's the key thing here. You have a specific set of APIs that are supported and are independent of the compiler internals.
So Matt, can you summarize why Swift added the macros?
I could try. I think general the idea is just like in other languages that you need to have code that manipulates code. That would be one sentence summary. But you also don't want the code to manipulate too much code. So it's not a C-style macros. I would say these are also hygienic macros.
Yeah, I haven't seen the Swift implementation or this the new macros thing.
I mean, I feel like the Lisp answer was always, we wrote the wrong language. So we're going to use macros to turn Lisp into the language we wish we had, and then we're going to write in that.
Yeah, I have not missed macros in Java. I'll say that. Like, there's no Java doesn't have macros, but basically Lombok, what you were discussing earlier, that basically is macros for Java. So the question is, how did Java get away without having macros for 30 years?
Good
It has an
marketing.
exception. It has a
I don't
exception.
think it did. I think it failed miserably at filling that gap.
I mean, it does use
I
XML for everything.
I
It
would
has
argue
an
that
exception.
Eclipse and IntelliJ filled that gap. That things that were code that needed to be generated, you would right click the thing and say, generate the getters and setters for me, and your IDE would fill out the getters and setters. But they really solved it by leaning on code generation, and intelligent IDEs that did a lot of code generation for you made it so that you could use Java without having to type out the same getter and setter over and over again.
And recently, I feel the Java annotations with reflection processing of these annotations are kind of trying to wannabe macros, but they're still at runtime. They are not compiled.
Yeah, Maven for all things generation, but it's not really great.
You need the language support for macros. You need the type of the macros to be known. So you kind of annotate something with the macros, but you need the result of it. So in order to be more stable, that's a key thing. There was a paper which
I mean,
described this
certainly if you
kind.
let Eclipse write your getters and setters, that's typed code. Like
Yeah,
that code already exists at typing time.
but they are delegated to the Java compiler. There would be an error if the Eclipse generated the wrong code. So it wouldn't let.
So you could debate this with the merits of Spring, and if you've ever played with that, it is it's kind of like way too far down that rabbit hole of generated annotation based assumptions.
So why do you think people felt they needed that?
To reduce the code, to reduce
Sell
the
books.
ceremony.
I think it was mainly about decoupling, because you get a team of 500 people working on something. The fact that they're always stepping on each other, you need something to yank them apart. And that was Spring.
How Spring yanked them apart?
Well, by the dependency injection. So basically, you used to have two modules that interreacted. So you had teams building those two modules, and they were changing each other's modules all the time to keep them lined up. And instead, what Spring says, Spring's like the parent that kind of wades into the battle going on the playground and separates the kids. They're like, no, you stand over here and you stand over here. If you need a shovel, I'll go to the other kid and get it for you. It's the parent that interjects themselves and walks back and forth between the kids to keep them separated. So now, I'm not saying it's the right answer. I'm not saying it's beautiful, but that's what it is, right?
And Ecstasy solves that problem by putting the kids in different containers.
That's a good question. Maybe.
How does it? How it does that?
That's the thing, until people are actually using it in anger, building big apps, it's hard to say if we've solved the problems or not. Like we imagine that we kind of did. So we have injection into a container. We also have when you pull a module into your type system, as so when your module depends on another module, you can say, hey, I'm going to provide some of the dependencies for that module that I depend on. So there, even within the same container, you get some amount of control over, or you can get some amount of control over injection.
So that's an interesting concept. How do you manipulate if the module depends on the module on some other modules, which in turn depends on some other module? Do you manipulate the whole chain? Can you say that this module would provide it from over here? I want to replace this module with some kind of other module. So do you have a view inside the internal structure of this, or
not a replace per se, but in terms of injection, as long as it's a directed graph, yeah, you can provide, each layer can provide injection to the next layer in. So, and that's within a single container. Anytime you create a container, you own all the injection for that container.
I got a question about this. So let's say somebody added some kind of like new network functionality. How do you inject that or prevent other containers from using it? Is it like a whitelist or a blacklist, or because it sounds like things would break if you add new functionality, if it's like not or depending how it works.
Well, for functionality, the injection is an interface. So if the interface changes, then if the interface changes, so there's two different versions of it, then there's a potential for verifier error. So for example, if you try to deploy something that needs the newer version, it's got what we call a fingerprint, which basically means, think of a fingerprint like what you prepare for the linker. It says, it has like unfulfilled an unfulfilled list of needs, and the linker's job is to come in and kind of put pointers
That's not helping your case.
Well, I mean, it's modules. Like, what are modules other than pre-linked things, right? So, I mean, it's in the nature of the problem domain. So, just because we call it something different doesn't mean the problem goes away.
Yeah. It's a different side of the problem.
But generally,
for Xity that I can have a long running service and I'm just replacing code of pieces of the system over time, or that I like stop and start a new instance?
Well, because it's container based, in theory, you could spin up a new container to do kind of an A/B switch over or something like that.
Yeah, it's starting to make me sound like the Erlang, leave the thing running for 10 years and just continuously swap out pieces.
Yeah, we're not there yet, but that's certainly a fundamental part of the goal is being able to containerize so that you can lose an entire container or spin up a new version of that container. Run them side by side so you can you have one kind of behind the firewall and the other actually serving, the old one serving traffic, the new one you're feeding the same request to see if there's if it's failing, so you can.
So this is embedded in the APIs. So how do you do a A/B switch?
No, that's not embedded in the APIs.
So your JBoss main container would like see new jar files and then bring in new sessions on a new instance of those jar files that are brought into a class loader. But that doesn't last 10 years because every couple of days you really got to bounce the Java virtual machine to clear out all the cobwebs.
Yes. Yeah, I mean, JBoss is notorious for accumulating cobwebs, something to do with Universal Class Loader 3. I assume you know what I'm talking about. Mark Fleury's last code he ever wrote, the class loader that broke JBoss for about a decade. But yes, kind of same idea that you could spin up a new version and then bleed over traffic to it, etc. But those are not things in the language. Those are things you would do much higher level.
That was my question. How do you provide a mechanism to say switch slowly to this new version? 5% of 1 hour, but how to slowly move to this kind of new service?
Right.
How
so
do you provide
that's the responsibility of the server that's hosting those subcontainers. So as you deploy a subcontainer, you're starting to feed requests into it, but your server created that subcontainer. So if you're bleeding over traffic, you create another subcontainer and then you start choosing where to route the requests based on whatever the rules are you're operating on. But we haven't written that ourselves, but that's the concept.
That's the purview of Netflix's tool that we're going to break 25% of our network every other day, and we just have to keep running. And I don't remember the name of that tool, but it's
Chaos Monkey.
yeah.
Chaos
Chaos
Monkey.
Okay.
Monkey.
Yeah, that.
So,
That's
but they're
way
pretty
beyond Java.
careful with that, because you don't know this. They made all of the precautions to record that this is indeed a job of the killing the machine of the Chaos Monkey, and record, because pretty much this can spiral out of control, because they have to tightly control that.
I will say, I feel like I
GCC,
learned a lot about the ways in which systems evolve from the stories of Chaos Monkey. I've seen systems that had a Chaos Monkey that they got into some kind of weird state. So they turned off the Chaos Monkey. They're like, we don't need one more thing messing with our system. And all of a sudden started seeing anomalies all over the place, because it turned out that the systems had evolved in an environment where 25% of processes get killed each day. So nothing ran for more than 5 days.
oof.
And if all of a sudden you turn off the Chaos Monkey, you've changed the environment. Systems that evolved in the presence of a Chaos Monkey can sometimes break when the Chaos Monkey is turned off.
You can never get it perfect. There always be trade-offs between one and the Chaos Monkey is the point to always not rely to something to be stable for that much long. You have to intentionally break it to see how it reacts. Or did you introduce something that would collapse a large part of the system? That's it.
GCC and Clang need a Chaos Monkey because every time I try to use profile guided optimization, it makes my code slower. Yeah.
So I've always wondered what does profile guided optimization rely on too, because you don't have a real profile data. How exactly would help the profile guided optimization once without data, without real data? How would it optimize it?
Well, when I do it in C++, it requires a run that collects some data, but it
Some data,
doesn't
but on
do any good.
and if it doesn't run on a production data, if you will, so how does it collect its profile?
All you got is your unit tests.
Or whatever the tests are. Yeah. I mean, the idea is that you're just trying to highlight to the optimizer which things are on the order of 0, on the order of 1, on the order of in between.
Millions in my case.
Yeah, well, I was going to say in between, and then there's an infinity. I mean, so you have a very, you're just looking for orders of magnitude, really.
There's only 2 really hot functions in my code.
Generally, you do not want to run profile-guided optimization on your unit tests ever, because your unit tests are usually the most extreme cases exercising the weird edges in your application that will never occur for an ordinary user run. So you are pretty much going to have a guarantee that you will train opposite to what the user application is going to do. And that will make your application slower. So I think it's better to avoid using PGO rather than training PGO on unit tests, if that's the only choice.
Profile guided optimization is only optimization if you have a real data to optimize.
Some kind of representative profile, and this is hard. And don't assume that this is going to be easy and you can cheat using unit tests.
So don't listen to Matt, because Matt wants all his edge conditions to be slow, and those should be the fast ones. Just kidding, Matt.
Maybe for high frequency trading it makes sense, because then you often have the case that it's when you have some weird thing in the market and you have very lots of trades that's something that almost never happens on the regular trading, then you want to optimize for that, when what is called is actually the important part of the code, and what is hot, what is the frequent profile, may actually be not what you want to optimize for. So that's one interesting edge case of the edge case.
That's one of the longest bets I lost. I bet one of my fraternity brothers in 2010 that by 2020, the reputation was going to be you can't use ahead of time compiled languages because they're slow. Because I figured you never get good profiles ahead of time. You do get good profiles in a runtime environment where you're just jitting code. And I thought we were going to get to the place where the reputation was that V8 and the JVM were just much faster than you could ever get C code to run.
But
And in
they
2020 called and was like, so is the reputation that JITs are fast and ahead of time is slow? And I was like, no,
I remember this
lost my
argument,
10-year bet.
and actually that's something I slightly have a different impression that Cameron, because that, to my recollection, that was the marketing of Java. And I remember, I'm not sure if it was Sun white papers in the 1990s claiming exactly what you just said, in that JIT compilation is going to outperform necessarily ahead of time compilation because JIT compilers will be able to optimize at runtime in a ways that ahead of time compilers will never have. And it wasn't about small getters and setters, it was things like hardware specific MMX instructions on your Pentium that is only going to be ever supported well by the JIT compiler because your ahead compiler will never be able to do that. So I remember those arguments in the 90s.
There were definitely some marketing papers in that vein. So I actually remember some of the arguments, and they were actually technically quite reasonable, which is, should your ahead of time compiler have to produce these multiple paths to optimize for these multiple CPUs? Because you had, at the time you had MMX, you still had machines running that didn't have a math processor, right? You still had 386s running without a 387. So you had to have two code paths, one to do the floating point by emulation, and one that is to do it in software, and one to do it by dishing it out to the FPU. So the argument was within that context. We're jitting on the machine. We know what the hardware is. So we can produce the FPU code if the FPU is there, or the non-FPU code if it's not. And by doing so, we're saving at least one if. That should definitely pay for the JIT. Look, I mean, it was a different era, but it's not a technically bad argument. It's more
that. I mean, trend prediction doesn't exist, of course, and the dynamic dispatching like iFunk or multi-versioning does not exist.
Right.
I mean, there's also another aspect I find pretty cool about JITs. That theoretically, if you have an application and let's say you dynamically link against some library, then like something like a memcopy or like libc or something, that where you're doing some kind of things. And well, if you ahead of time compile something with a dynamically linked library, you can't inline everything because maybe that's like the point is to be portable. The thing is, a JIT can, once deployed, actually see through all of these dynamic libraries and then inline everything, and like across these dynamic libraries. And the thing is, the power of inlining is also to be able, I mean, this seems like sci-fi, but technically if you inline if branches like far enough into your main code, then you can suddenly like see lots of opportunities for vectorization. I highly doubt that JITs would probably do that, but
the inlining is the mother of all optimizations.
I just don't know if JITs actually after inlining then like vectorize code that was previously not vectorized. Like I don't know if they do that.
Yeah,
Clang is really bad at vectorizing a lot of my code or a lot of sample code. Cameron, you're gonna have to help me with this one. What's the joke? Is it 2 times or 3 times? Going from C to Java is like 3 times slower, and then Java to C is 3 times.
That's not necessarily the case.
We ported C++ code to Java, and we saw about a 3x slowdown. And then we ported Java code to C++ and saw about a 3x slowdown. And so, and the reason is because it makes sense when you stop and think about it. It's not actually that crazy, because the original code was written for that language. The Java code was written to be optimal in Java. The C++ code was written to be optimal in C++. And so when we ported it, ported straight port, that is not trying to change the design, not trying to change the data structure.
You took a creature out of the environment in which it evolved.
Yeah. And it's like everything we were doing in C++ to avoid, so we would malloc a single array full of objects, one malloc, and we have the whole thing. Or we'd region allocate for a bunch of work. So we'd be replacing one slow malloc, because malloc is fucking slow compared to Java's allocation. We'd replace one alloc in C with 143 million Java allocations. And even though the Java allocations were 10,000 times faster than malloc, we had 143 million times as many of them. We just couldn't win, right? and so then you optimize for Java, where it's like basically everything is automatically region allocation, just because of the way GC works. And then you take it back to C++, you basically do direct port over. And so all those news become mallocs. And it's like, oh my goodness, C++ is slow. But it's because each one was coming from.
The solution you develop is specifically attuned to the language you use, the instrument you are using. So it's so detailedly tuned, so you can't just port it to another language and assume that will do the same thing.
I have a real solution, but go ahead.
Okay, go ahead. We are waiting for it.
Well, I take away your memory allocations from you. The compiler decides if something's on the stack, if it's allocated, or if it's passing in a pointer as a hidden parameter.
The JVM decides to.
No, it doesn't do that. JVM does.
It does do that.
JVM pretends that everything's on the heap, but actually puts almost everything on the stack.
While it can, and move most of the things that it can on the stack, because it can calculate its lifetime, for example.
I'm pretty sure if you had a loop with a million news, it's going to do like roughly that many and not reuse them because it's not collected. And my language would just not do more than one if it goes out of scope right away.
But what do you do with the million allocations? That's the point. If you use all the million allocations, so how would you escape that? If you use them one by one, then reuse. That's
yeah, but that's my point. Java doesn't do it one by one. It would just allocate it with a bump pointer or whatever the GC feels like doing.
I've never tried it, but from the legends I've heard, you can spend a lot of time turning heap allocations, stack allocations. And if you have a really good young gen GC, it doesn't actually save you that much. GC.
It saves you some memory.
What they do.
It saves you some memory bandwidth, and that's what Cliff talks about a lot.
Well, after 15 years, Java came out with escape analysis in the JVM. So, that is sort of the definition, finding opportunities to replace heap with stack.
Right. And quite often it looked slower than not using it, which was the other frustrating thing, because they did a pretty good job of it, and yet it turned out in a lot of use cases to be slower, at least initially. I haven't looked at it lately.
It was extremely limited and narrow at the time. Still probably has some room for improvement.
I'm just going to assume that back in the 90s, when people were writing about how the JIT's going to take over the world, I'm pretty sure Java was still 3x slower or even 2x slower. And they seem to not notice memory was going to be a problem. I don't understand that.
It depends on the domain. Java had a lot easier time of doing reflection-based, assemblies out of the gate. Even in Java 1.0, you didn't have C++'s munging locking you in to your, crazy compilation.
Yep,
that was a huge jump.
I remember Amazon's website, which was built in C++. It used to be called obdos.exe. I don't know if you remember that showing up in the URL. It was actually a Windows executable file built in C++ and deployed to Windows servers hosting the site. And it would last, a typical server, I think, would last about 5 minutes before it had to be restarted. So they had thousands of machines constantly crashing. And every feature they wanted to add was, a 6-week process. So, it was, I don't actually remember. It was 6 weeks. I just know it was a long time, because you have to actually rebuild everything, make sure you can move from version N to version N+1. And the reason they switched to Java, and that was about 99, I think they started switching. It's been a while, so I can't quite remember. It might have been 2000. Anyway, the reason was because they could partially redeploy. They could, so all of a sudden, a bunch of things that they just couldn't do in C, C++ became super, super easy in Java. And actually, Amazon was one of the bases for a presentation I did years ago about why Java beat C++.
I just realized something. Go ahead, though.
Go ahead.
It's related to what you're saying.
Go ahead.
All right. People or at Bell Labs or whatever, they wanted C++ to be part of an ISO committee, and no one put a shit ton of money into it. Like Sun put a lot of money into Java. So now that you were talking, I just realized that there's probably never been a really solid tool for C++ ever. Like maybe Clang is kind of now, but not in those days.
I mean, C++ runs our entire economy at this point.
It
So there's got to
does,
be some
but
solid
no one
tooling.
likes it.
When you say C++ runs the economy, I mean, it's obviously huge, but it's
It's the firmware in the cars and the factory automation, and it's most of what most of the operating systems are, and it's most of what most of the databases are.
Oh, so you mean C and also C++?
Yeah, I was about to get a stroke. Yeah, C, I don't know. I don't think many operating systems are written in C++, and I think
Well, Windows
That's true.
is.
The operating systems are C.
Yeah, and the drivers are C, and yeah, I mean there are some things that are easier in C++, but
I
operating
thought Windows
systems and
was
drivers
completely
not.
C++.
Windows, I believe it's C++, most of it.
I don't
Yeah,
know.
that's also my recollection.
Yeah,
So Linux is obviously
it
C.
used to be all C, other than
Linux
write.exe was written.
Linux is written in object-oriented C.
Yeah,
If you look at things like the driver stack or the networking stack, it's actually heavily object-oriented with very, very classical object-oriented dispatch. That's kind of interesting.
Right.
You can write it in any language, of course. The object-oriented stuff.
Was there any really good like compilers that you had to pay for that was like that didn't just make their money on producing more efficient code?
I started on Borland C, I think it was.
Semantic
I don't really
was
remember. I was
super
basically on
good.
GCC by the time I started taking programming.
Semantic compiler was slick, and the code was pretty good up until you get to comparing it with Watson from IBM back in that time.
All right,
Because I know people pay for ReSharper, but I don't know if anyone pays for a compiler unless if it made efficient code for whatever embedded system they're running on.
All right, so Levo, you want to see why my old presentation on why Java beats C++? See if this holds up well after 15 years.
Yeah, sure.
I'm just gonna assume it's like C++ is shit, and then that's all there is to it.
C++ isn't shit. It's just shitty. There's a difference.
Whatcom, I don't know if how many remember the Whatcom C compiler, but that was useful in the game industry because it was shipping with a memory extender called the DOS4GW, which allowed you to use extended memory in DOS.
I'm going to remove the bottom of my slide for some reason, but anyway. Yeah.
So because those colors are so subtle.
Yes, very subtle. No one knows where these slides came
from. Yeah.
These are all online somewhere. So basically, the question I was asking at the time was like, why did the overwhelming massive group of developers move from building primarily in C++ to moving to Java and C# and other languages like that? At the time, Python wasn't that big, but I would argue that Python falls into the same explanation as what I'm about to go through here. Right. So this is Java in the eyes of the Java programmer, right? Java in the eyes of the C++ programmer. Am I hitting any notes for you there, Levo? Java in the eyes of a Ruby programmer. Anyway, so top 10 reasons why Java supplanted C++ with the obligatory disclaimer. Don't go fanboy on me. So biggest reason I actually think in retrospect was garbage collection. But
Yeah.
not necessarily for the reason you think. It's this middle one here. Garbage collection isn't about saving you from calling free or saving you from calling alloc. It's that I can take 50 modules, each of which grab modules that they didn't use in their previous version that I had never heard of when I started using the previous version. And I can pass in an object and it passes the object over to the next one and then so on down the chain. And no matter what, when we're done using whatever that object is, it just disappears and I get the memory back, right? So there was nothing like this in C++, right? And Matt, don't argue because I know you can like give me the technicalities of how to do it. But generally today, still, there's nothing like it. Don't go all smart pointer on me,
Unique
please.
pointer, but
Well,
Yeah,
no, actually, I would say if you look at the libraries today, like TensorFlow, which
Yep.
is a C++ library, that uses C++ and that uses RAII. And that's a fairly standard construct since the 1990s.
yes.
And I remember those discussions on Usenet about garbage collection and that you need to jump to smart pointers. No, I don't think you ever actually needed smart pointers that much. Wrapper classes like the standard vector with RAII get you most of the way there.
Yeah, no, RAII is actually a great solution as long as all your control flow is hierarchical, you're done. Like GC is just pointless if all your control flow is hierarchical and if your object lifetimes correspond to your control flow, you're done.
well,
like,
I would argue it should be because otherwise your code is spaghetti. But that's just me.
well, it's the difference between college projects and real world applications. Like college projects, yes, it's 100 lines of code for the biggest project you ever write, and you're done, right? It's like you write a compiler for a new language that you have to create in your class, it's 100 lines of code, right? You write the application, it's 100 lines of, like everything you write is 100 lines of code and you're done, right? And then you get your first job and they say, I need you to fix a bug in this. And you're like, where's the repository? And you download it and it's 600,000 lines of code and it's got Spring all throughout and you have no idea what's connected to what. And your job is to fix it. But on the other hand, you had to pay 100,000 a year for college and now they're paying you 100,000 a year to fix this thing. It's like, that's the way the industry works. So the build process. Yeah, so I've told you guys before about some of the long builds we had in C++. Same thing built in Java, 7 minutes, which at the time was horrible, but it wasn't 20 hours. Then you need a debug build. Oh, gee, like, yeah. That's a fairly minor one, actually. Simplicity of source code and artifacts. Yeah, I mean the header versus the CPP and the HPP versus CPP thing, and the fact that you had to know where to put things. Like, oh shit, if I put this in the header, it gets inlined. If I don't put it in the header, it doesn't, like all that stuff.
Yeah, that's the worst. I got a question about the 20-hour compile time. Do you remember how many lines or how big the project was?
Yeah, it was less than 200,000 lines of code.
It
But
took
it
20
used,
hours,
but
or
it
how
used,
many actual
it used
hours?
templates. 20 hours. 20 hours of
It actually took 20 hours.
20 hours on a 16 CPU Sunbox running the Sun compiler, which is the reason it was 20 hours. But yeah,
Jeez.
20 hours. I think we got it down eventually to 14 hours.
Do you know how fast the megahertz or gigahertz of those CPUs were?
They were probably 440 megahertz.
Okay.
It was 16 CPUs, 16 UltraSpark 3s, I think. Yeah, I mean, it was your typical $500,000 piece of kit. Fortunately, we had bought Sun, so it was free. Oops, let me go back. So binary standards. So this is huge. This one actually goes with the garbage collection, by the way. The binary standard of Java is what lets modules get, you just drag in shit. Like before Java, and again, I'm a little older than most of you guys, so but in C++,
Yeah, you can load an ancient class file in the JVM today, and it loads.
So let me tell you about the number of commercial C++ libraries I used before switching to Java. That's two, total, two. And neither one of them was any good, right? There's one of them we inherited and the other one we had no choice about, right? So two libraries. And the reason is because if I had added a third library, the company would have gone out of business. There's no way to use libraries in C++. Matt, please don't correct me. I know you're right. That
We had code generators for that, particularly around Corba. We had shells that you would write a pseudo C++, which would create the assemblies linked together by Corba, doing your memory management and templates, and and proceeding.
But that's the first conversation we had today about Protobuf.
Oh yeah.
Is this C++ has no binary standard, or C and
That's right.
C++?
There's no binary. Well, C is a little better, but C++ definitely has no binary standard. You cannot export a class from C++. Like,
yeah, because if the library does not have a C interface, then I can see how that's a huge problem.
Right. But the other thing is Java, like a Java class file, is just as good as having the Java source file, and that is not true in C++. So basically, what it meant, the garbage collection plus the binary standard meant that you could just easily grab all sorts of shit, almost NPM-like. And I'm not saying that's a good thing all the time. It's often a horrible thing, but it is kind of the cathedral and the bazaar concept, right? We had never had a bazaar like that, a bazaar. We had never had a bazaar in the industry. And suddenly it was like, if you look at the number of libraries that appeared in Java in, say, 10 years, the first 10 years, so from 95 to 2005, it was probably 20,000 public libraries that you could just go and grab. And in C++ at the same time, there were probably 3. There was Boost, and there was Boost. I can't think of a third one. Like, you just couldn't do libraries.
Did you say open source? RogueWave was big.
Yes.
I would say package management. I would actually kind of agree with this, but I would say it's not the binary standard, but rather package management standard. Today,
it goes together.
Today, you are fine with recompiling. I mean, that's, I think, standard practice everywhere. You do recompile third-party components from source. And it's often even good for integration is that you want those recompilations to happen in your CI on a daily basis. But you still need package management standard. I would say that's still a weak point.
So Jim, RogueWave was one of the 2 libraries I had to use. So yes, I'm quite acquainted with it, and it was a pile of shit. Holy cow.
It was amazing, man. Built in
the 90s. In the 90s, people didn't want to give you their source because they were pretty sure you'd fire them if you saw it.
Something like that. We used to think source code was valuable. That's the whole. So the dynamic linking. So this is the other side of the binary compatibility, Lilo. With Java, like, you'd have an app server, and it could take an app, and it didn't matter if the app was built before the app server was built or the app server was built before the app was built. It just goes in. It's like the same app could go to Tomcat, could go to JBoss, could go to WebLogic. In theory, anyway.
I mean, there are DLLs.
There are not DLLs for C++. Stop and think about it, because I actually worked on this in the 90s.
They are, but that's the other side of binary. So nowadays, C++, for better or for worse, has so-called stable API expectation. What this means is that today, if you propose something for C++ standard, and you would change API, it would be rejected. This is a new field. This is, I would think, this happened far after C++ 11. C++ 11 is famous for making this huge breaking change to std string, because standard string used to be copy on write. That didn't play well with multi-threading, so it's not copy on write. Excuse me, and that broke API. And now it turns out you actually had a large amount of commercial users who regularly ship C++ DLLs. Adobe, for example.
Wow.
If you use Adobe Photoshop, most plugins you will use for Adobe Photoshop are C++ plugins, which means you do actually require stable API, as we have learned. So nowadays you will you will not have proposal like standard string breaking its API, because it took something like 10 years to adapt the ecosystem, to move the compilers of every commercial company shipping the plugins. So for better or for worse, it has some kind of DLLs, but maybe it would be better if we were all recompiling from source, because there are some optimization costs.
I'm going to
or
claim
not
that
changing
I wrote
ABI.
this presentation before C++11, long before C++11.
Of course. I just adding current. That's very enough. Just adding current
but the
context. And I'm
last,
not sure it's a good thing, actually. I'm not sure if it's a good thing because always recompiling from source would allow to optimize a lot of things that are now kind of frozen or semi-frozen.
and it
So
only
maybe it's
takes
better
20
not to have
hours,
that.
only takes 20 hours to compile.
Well, now we have
Cameron,
more cores, so maybe only 19.
you're getting more of a reaction from other people than me.
So the last big C++ project I worked on, and this was in the 90s. This is the last.
Oh, you're happy then.
The last big one I worked on was with COM and OLE2, and I was producing native code on the fly because there was no dynamic linking for C++. So what COM was, the COM, the component object model, COM was Windows solution, Microsoft solution for the fact that they couldn't export C++ classes and DLLs. So COM allowed them to export C++ classes and DLLs, and it was a hugely complex way of doing it, but that was the way you did it on Windows. And OLE2 was just the pile of APIs built on top of that. So I actually generated for a 4GL, I was generating the native backends that would export so on the fly I would create these COM objects and then map them back into existing code and stuff like that, so I could export C++ stuff. Anyway, that long.
Too lazy to use VB.
Yeah. Portability. I mean, this one is less of an issue today. C++ has gotten more portable, and Java maybe less.
I disagree when people say C++ or C is portable because there's always a bug, always. Even
Right.
if it compiles.
But it's more portable than it used to be. How's that? But it used to be C++ was very unportable. And the other thing was, there was one point I was working with 3 different memory models because I still had 16-bit code. I had ported it to backwards from 32 to make the 16 support, and then I had to port it forward to 64-bit. Yeah. Standard type system, Java didn't have the STL issues that C++ had. So C++ kind of started without a library, then talked about getting a library called STL, and then waited 20 years before actually doing it. So that was a huge one. And then reflection. You have RTTI in C++, but no one used it really.
Yeah, I turn it off.
Yeah. So in reflection, though, the nice thing about reflection is you could have, an application and 2 different libraries, and neither library knows about each other, and the application was written long after those libraries were created. So say Hibernate and Spring as 2 libraries in Java. So Hibernate could be taking those application classes and sticking them in a database, and Spring could be wiring them together, and none of them knows anything about the others, right? And that's all because of reflection, and that's huge. Performance, yeah, I mean, it's kind of a debatable one. And then the safety was huge. I mean, this is fundamentally why a lot of companies, gave up with C++ for anything that had to evolve faster than an operating system. And then templates, of course, were just horrible. But okay, so then this is kind of the flip side. Like, where does it fail? Startup time. The startup time of Java was 3 or 4 or 5, 6 orders of magnitude more than C++. I mean, just there's no comparison. So if you have to start up, do something, and go away, like Java's always going to still be 1,000 times slower. Even if it's fast now, it's fast compared to human wall clock time, not computer time.
So to play devil's advocate now, do you think Java is going to get better now with the move of compilers like Graal to ahead of time in compilation?
I think it'll get incrementally better, but fundamentally the design is such that there's just way more work it has to do. I can't see how.
That's not true. Like there's Azul. I posted this work. Like they have, what is it? It's called Ready Now.
Right.
So all they have to do is load the compiled code from disk, and like, sure, it's about as expensive as loading a DLL. That's
Right.
not
right. So they get it down to 20 milliseconds now instead of 2 seconds. It is awesome, but that's 20 milliseconds compared to 0 for C++.
We
no.
had
It
compiled
lot of
Java on SGI, which had caches that were instant to load for Java 1.0. SGI wrote their own compiler for Java, and that was the cat's ass back then.
Wow. So, sorry, Alan, what was the rest of that? You were saying it was faster?
Yeah, I was saying that, like, loading like normal C++ code is also very slow because, I mean,
No,
you can you if you're lucky, you can memory map the stuff and it'll like it doesn't have to do any like relocation of symbols or stuff like that. It just directly memory maps it. But then it still has to load from the disk into the memory, and that costs about as much as loading JIT code from disk. It's
Address layout randomization costs
right.
as much as loading it.
Interesting.
So.
Memory footprint, there's no comparison. I mean, you port something that uses 32 kilobytes in C++ and it's going to be 30 megs in Java. Now, you go from 32 kilobytes to 100 kilobytes in C++, you might only go from 30 megabytes to 31 megabytes in Java. So it's not on the same slope.
You know what you can do nowadays? Compare this to npm, cargo, and pip. It's going to look really good compared to those.
Today, I would say also memory bandwidth and memory latency. I think that's the problem, that we hit memory wall about 20 years ago, which is maybe also more recently than the presentation has been made, and the indirection, which is the default in all reference semantics-based languages, I think that's becoming a killer now.
Yeah, this
for
was
most
just
applications.
this was just about the time that the multi-core CPUs started coming out. So
okay, so that was already around the time of memory wall, I would say.
By the way, compliments on the image choices.
Oh, thank you. Yeah, so Java didn't have RAI. It had try finally, but it's just not the same.
Was there a lot of problems with file descriptors with Java? Like it would force a lot of collections because it ran out of file descriptors?
No, that was in the 90s. There was some, and that's where if you Vornado, I think it was called. What was the guy's name who did the benchmarking and stuff on who could do the most concurrent connections and stuff? It was the Vornado mark or something like that. It sounded like tornado. Volano, Volano. Look up Volano mark. It was like he did tests with every release of Java and stuff, comparing operating systems and so on, how many file handles before it would fall over, how many network sockets before it would fall over. And see, back in the 90s, the thing you don't appreciate now, Linux supported less than 10 sockets open at the same time in the late 90s, and then it would die. And I mean, it would die horrendously. Like you'd have to buy a new computer. I'm exaggerating a little, but not much. Like,
wasn't it still using interrupts in the network stack when you were receiving network connection? Yeah, and you would have this cascade when you have more interrupts, and then the system would do nothing but process interrupts at some point. And that point came early.
There was a lot of that. And the joke at the time was Solaris, everyone called it slow Laris. It was slow. And it was actually slow, but it was actually the most stable operating system you could get outside of 390, the ZOS. But Linux caught up quick. So by 2003, Linux was pretty close to solving the C10K problem already. So it basically went from being able to support like 10 threads to supporting 10,000, in just a couple of years. And same thing with sockets. So that was, I guess, yeah. So native integration, Java sucked. they're just solving that now, actually. So 15 years after I wrote this, they've pretty much got it solved. But anyway, the point, all this is debatable and everything else. But the point
I think they'll have gotten native down by 2030.
The point I was trying to make, though, is not so much that one is better than the other. It's that what were we trying to do while all this was going on, right? So you had internet and the World Wide Web, right? You need to be able to rapidly deploy applications on the server and change them and so on and so forth. And you can't have them blow up, right? So it's like if Word blew up and your mom had to restart it, it's like, okay, no big deal, right? She lost a day's worth of typing her novel and she has to start again or whatever. But when Amazon blows up and it's the Christmas season, like they lose lots of money. So the browser's on the client. So that's obviously something done in C++, but
today I guess the slide would be titled "Understanding the Shift to JavaScript."
Right.
Possibly WebAssembly.
In Python. Like, why did Python clean everyone's clock in the machine learning space? Right. So you look at what people are actually trying to do and then measure it against what languages are actually capable of. And that's when you see the shift, right? Because C++.
That's a good point.
Go ahead. Sorry.
Okay. Yeah. In 1994, the only Java that we could get access to was pre-release. It was the applet demo. You had, 4 little class demos. So anyways, yeah, it is impressive what Java has done starting from an applet-based platform that is intended to run inside a browser, inside C++.
Yeah.
Yep.
So it's this point, though, that we needed fast iteration on the development side. There was no way you were doing this without a ton of class library support because, just the amount of complexity, et cetera. You needed some modularity to do that. You had to have long-running capabilities, so no memory leaks, no GPFs, no seg faults. And you needed multi-threading support. You couldn't do multi-threading in C++ unless you were a freaking genius, and even then it was unsafe, and so on and so forth, right? So I look at but mainly that's kind of the main point of this. It's not that Java was better. It's not that C++ was worse. It's that everything we were trying to do needed the things that Java did well, and C++ just couldn't shift to do those things. Anyway.
I still feel like C++ was just worse, especially after seeing a lot of binary outputs. Like every time I look at assembly, it's awful. Even in C++.
So what's the next topic?
I was curious about something. So last time there was a bit of a mention of this, of the Chandler Cruz talk on CPPCon about like making his parser fast and stuff. And
okay, before we get into that, because I know it's going to be a long topic, I just want to quickly ask about Python being used for machine learning. I don't know how many people here uses Python, but I kind of suspected that the reason why Python is used is because that's like the only sane API to PyTorch or TensorFlow or whatever. So do you guys know more about this?
It began earlier. Like the reason, one thing about Python is it has basically zero learning curve. It's extremely easy to set up. It has REPL. And it had like a very, very big similarity to MATLAB. So and lots of the numeric packages and math packages were all super similar to MATLAB.
Yeah, Python was there first in the community, so it's that you're more keen to using something that has something that works in order, and instead of building it for 2, 3, 4 weeks, maybe months.
Ecosystem momentum, basically. Yeah. Once you already have a huge ecosystem of libraries, then incrementally building on top is much easier than rebuilding the entire ecosystem.
So I assure you, I've had tried stuff from the beginning, from 2015, 14, 15, 16, that this stuff was about to take off and wasn't that good. But this was the only thing that kind of worked. So that was my opinion.
Even before like the machine learning took off with Theano and stuff, like already there was a big ecosystem. And the other thing is, I think academics, like especially ones who are not in computer science, don't really care about like sophisticated languages, because for them it's like a cost center kind of. So they have like other priorities.
The benefit thing here was the Python is like a descriptive language. You're used to descript your operations, but beneath it was all C++. That was a huge stepstone in order to bring adoption.
Why didn't Java have a better ecosystem for AI? Because Java had an ecosystem for everything.
Cameron name it most of the things for Java, but they just wasn't in the markets. So for
and they couldn't do native integration well.
Yeah, that's
so Java.
I would say maybe someone just mentioned that the academics using Python, non-computer science academics don't really care about computer science elegance, right? And so one of the things they do not care about is some people's dislike of operator overloading. If you have someone coming from the data science, they want to write matrix A plus matrix B as A plus B, and they do not give a flying about someone disliking operator overloading. That's no Java.
The machine
doesn't solve their problem.
I want to point to make the machine learning problem was a multi-site problem, if you will. Most of the scientists write in Python, but they wrote the science part of the algorithms of the neural networks, if you will. But there was a side problem that someone has to make them run faster on the hardware. So these are both both problems from the same perspective, but they are solved by different peoples. The same peoples just wanted to write algorithms and make stuff work. So, but they still have to have the hardware library support that algorithms. If it doesn't run fast, I'm not so certain that there will be there will be this kind of quick adoption. That's at least my opinion, of course.
Adrian?
Yeah, all right. Yeah, so I like the topic. I was a bit into machine learning as well, and then I fizzled out because I don't like this type of work. So yeah, no, basically, yeah, last time we talked about this, we mentioned this talk of Chandler Caruth and the fast parsing and stuff, and he did mention memory efficiency, especially of ASTs, how like there's a huge ratio where the parsed ASTs in Clang are like 50x of the source code bytes. And so I was curious, just having a look at my own compiler, looking at memory efficiency, and like so the normal thing is, like, let's say we want to, like in AST, we have lots of recursive or recursive-like data structures, right? We have some kind of like nodes, maybe expressions and different types of it, and then represent them maybe as subtypes or tagged unions or something. And well, if you're in a garbage collected language, and you can kind of define it recursively, and everything is done for you in a nice way. But if you're in a systems programming language, because I'm writing a compiler in Rust, then you will use indices or something that point into an arena. And the thing is, I was doing, like, the thing I was paying attention to was making sure that the variants of the enum are individually small as possible. So, for instance, like a slice, a fat pointer, if I know that the maximum size of the slice will be below a certain amount, I can like allocate a few bits for the length of the fat pointer, and the rest for the address or the index. And the thing is, like, this is fine, but it doesn't actually help with enums where every variant has a different size, because if the size vary a lot, you get lots of space inefficiency if you have a collection of these enums. So this is actually a bit tricky to solve. I mean, you can deal with it manually. Let's say, so basically the problem is you have a vec or just an array of these enums, and how do you store them efficiently? I can actually, can I share something? Like, is that possible?
Yeah, of course.
Sure, but I stored all my data pretty efficiently, and I still haven't gotten close to those numbers. And Matt, maybe you can tell us while Adrian is getting his screen up. Can a processor can one core evict L1 or L2 of another core? Because I wasn't 100% sure on that, and I haven't had time to read Agner Fog reread Agner Fog.
I think you can't do it explicitly, but
like, because I know my because when I looked up on my machine, it was a 16-way L3 cache.
But imagine
and
it would invalidate through a cache coherence protocol if you have something in the shared state and then you modify it, changing the state to invalid on the other core is what I'm thinking of. If that's what are you doing, are you having multiple threads banging on the same data?
So there's no data that's being shared except for two tables. That's a lookup table that's read only. But I did notice that my L3 cache is 16-way, and I was wondering if because all the cores are putting stuff into the L3, that it's just evicting because it's 16-way, it's evicting things in other cores. But I wasn't 100% sure like how the CPU because when I was reading Agner Fog, I wasn't paying attention to that, so I might have missed it.
What is the mechanism you would think between the eviction? Because I'm not sure either.
Pardon?
What is the mechanism you would expect to result in the eviction? I don't think that just putting something in L3 cache would be that mechanism. So I'm wondering if I am maybe missing something.
Because when I ran the test again this week, it looked like very few data was being missed. It was going to main memory, but it seemed like a lot of data was not in L2 anymore, and it had to go to L3. And I wasn't 100% sure on why that was. I was just worried that L3 might be reading from main memory a lot, but yeah, I couldn't tell that well.
Interesting. I would look at the performance counters. You may even have performance counters for the
I tried. I looked at
precedents.
so many, but it's just really hard because it doesn't give me the performance counters I want to know. I just had to like guess by looking at other things. That's why I wanted to try other CPUs. But yeah, when I get more hardware, maybe I'll figure it out.
All right, share something on the channel if you find out.
Okay, Adrian,
Yeah, I think we're ready for you, Adrian.
no worries. Yeah, okay. So basically, my sum type could look maybe something like this. So this is 16 bytes, and I mean there are a bunch of indices or something, but there's a big variance. So like if I store a bunch of B's or C's, I have a lot of overhead. Since I mean instead of 4 bytes plus a tag, but still I'm like I have like a pretty big overhead, lots of padding, lots of space missing, and it's just not so efficient. So one thing you can do is something similar to this idea of struct of arrays, where you actually have one array per enum variant, and basically some kind of like struct where
you have an array of A's, an array of B's or C's, an array of D's or E's.
Yeah.
And then you have an array of ints that point into them.
Correct. And the thing is, like, you can also one thing you can do is also you can recognize that there may be some like class equivalences in size. For instance, this is here like 0 size, so I just need to store the tag once, or just map the tag to the appropriate value. I don't need to store anything for A. B and C have the same size, D and E have the same size, so I just need a vec of maybe U32 and the other like a vec of like U32, and then like I can store B's and C's in this first vec and D's and E's in the second vec. And so I basically have perfect packing efficiency. And the thing is, after I insert something into this like this custom vector, I would get back a tagged index, because the index needs to not only know like the index or like at which position, my element lies, but also in which of those buckets. And the thing is, doing this manually is pretty painful, especially if you keep changing your data structure. And maybe you make a mistake with the size or something. Maybe even they have different types, but the same sizes. So you need to do unsafe transmutes. And then maybe at the end, like afterwards, you forget that you changed one of those definitions, and then all your code blows up. So it's actually pretty tricky. And that's kind of something you can't really, I mean, you can do it a bit with macros and code generation, for instance, in Rust. But you can't really exploit class equivalencies like in the size of the individual variants. So for instance, for Rust,
what's the size of expression? Is it going to be the biggest element, or is it
biggest element plus tag
B,
plus padding?
So if I use B, it's not going to be like 64 bytes or bits, I guess.
Well, no, the B element can be small. I guess it depends. But if you want to store like all kinds, if you want to have an array of expr elements, and you have a data structure that needs to store them, it needs to accommodate for the like worst case. But if you instantiate an instance of B, of course, like the constructor knows its size. So I think like that, then it can be smaller. But like I don't know, depends. Like,
it's weird. It's weird that you and Rust call this an enum.
Yeah. Sorry about that. I don't like this at all. I hate it.
It's a type class.
There are two things Rust does. Yes, they're just they're just gaslighting everyone, because that's not an enum, of course, and also like Rust calls their exceptions panics. So now everyone in the Rust community thinks Rust has no exceptions, but they do.
Is everyone panicking now?
Yeah, exactly.
So what happens if I add an F and my F contains an expr?
Aaron, you are choppy. Can you repeat?
He was saying add an
If I
F
add
to
a
the
pattern
enum.
F that isn't expr, so that it's recursively defined.
You want to add an expr here inside?
Yep, F vector.
That's not possible, because we're recursive without indirection. You need some form of indirection. You can do it with
so pointer to expr will be happy.
Box of expr, I believe.
Yeah, box. Yeah, right. You can do a pointer. You can do a box. You can do a reference that has the same lifetime or something. Like it's disgusting.
See, this has more memory management than C++. So it feels like sometimes this is more complicated memory management than C++. C++
because
just use a raw pointer.
Doesn't have memory management.
It's a share pointer, unique pointer, containers, or raw memory. That's like that's it.
On a side note, I see nothing wrong with Rust enums. Scala does them the same. It calls them enums. So I don't see nothing wrong here. So,
I would prefer if they were called like variants, maybe like variant types or something. But whatever. Like, okay. Anyways, I was trying to make the point that like making this manually is very error prone and unsafe, or it can be at least, especially if you have very like different types. Like this could also look like this. So they're both still the same size. So you could be able to pack them inside here and stuff. And the thing is, Rust macros only give you the ability to look through the AST, through the tokens, and you can technically construct something like this struct of arrays approach to storing every variant inside its each own vec, and but not like in this very sparse, very very compact way. And the interesting thing is, in Zig you can actually do this. That's why I was quite I was quite surprised about Zig and about the like this comp time thing, because at compile time you have information about the size of each of those variants, so you can just analyze them and then build your struct exactly the way you want, and make sure all the accessors and the pointer tagging stuff, like everything works out. And you can even give information to this like macro or comp time function about the expected size of your vec. Like maybe you can exploit some other things in your bits or tags or something. So yeah, it's pretty interesting, and I don't see many people do this optimizations. I looked for other compilers and stuff, and they don't bother so much with it, and especially the Rust compiler doesn't. But I think with the Zig, it's actually more doable than in other languages.
Are
I would
you about
say
to ask a question? Because I was wondering if you're asking about if it's possible to reach 10 million to Lex and parse, or if you're going to ask us how to make this faster, or if you're going to ask us something totally different.
I wasn't
Well,
actually.
nobody said 10 million.
Well, Chandler did.
Can you repeat? Are you asking a question?
No, I want to know if you were going to ask us, like if you're going to ask
Ah.
us a more specific question, because I wasn't sure if you just wanted to talk about this or if you're going to ask a question about this.
I believe he
No, I think
just
it was
wanted
just
to show.
explaining the what he was
Yeah.
able to do with Zig that he couldn't do with Rust.
Exactly.
Okay.
Yeah. I just wanted to tie in because we also talked about code generation and macros and stuff.
Oh, okay.
And
That's a
also,
perfect use case, Adrian. Yeah, that's a perfect
Yeah.
use case for a macro to write that.
Yeah, and this one's easy in C++ as well, because what you do is you have a custom allocator for the equivalent of EXPR. And then you size of round up to 16 and return you return the offset from the start of the slab, and you store the offset in the array. So you basically have it's double indirection, but you pack it tight, and you can even segment your custom allocator as well, so you don't even have to be smart about how much to allocate.
Yeah, I use a custom allocator for my parse tree.
Yeah, I mean that's a great example. Well, that's one of the reasons why C++ can spank a lot of things on the compiler speed, is because the region allocation and the fact that you have stages. So each stage basically you only have two regions alive: your previous stage and your current stage.
Yeah.
So.
But I would say if you go to such extreme measures, you have to figure it out, the layout of the AST and all of this, in order to go into such an optimization extremes, I would say.
I just think it's funny that we're so worried about stuff like that, and then you look at npm and they're like, yeah, 100 gig, no problem.
Yeah.
I mean, like the thing is, I'm working on like at work, I'm working on a Rust code base, and it's very big, and like the compile times are just like they're making me love C#, or I mean, actually C# is a good language. Never mind. Like they're making me love other things like JavaScript. It's really
that's a
painful.
good sign. That's a good
Pure
sign
pain.
for that a language is doing a lot more than the other languages. Scala has notoriously known for its slow compile times, and I hate him. I hate him with all my heart. But if you wait out what the compiler is actually doing, you can kind of halfly forgive that it's also slow.
Considering I wrote a compiler, I know a lot of compilers are just shit, just flat out shit.
By the way, one more thing, like about this, about the actual numbers that that Chandler gave in the talk. Like, so if your tokens or your Lexer is very simple or something, I think you can go above like 1 gigabyte per second quite comfortably. So you would probably be able to get like a bit more than 10 million lines of code seems reasonable. And the thing is, like I was not sure for code generation how much like if he was talking about the release build or the debug build. But if the debug build is supposed to be 100,000 lines per second, like the state of the art that like some of the baseline compilers do that I've seen in papers are like they're more than an order of magnitude faster. So I don't know. You guys can check out this copy and patch if you haven't seen it. But basically, they do 60 megabyte per second of like baseline compilation for I think for WASM, but they can also do it for AST stuff and they can actually just baseline compile AST directly. and not only bytecode.
How big was the input?
Actually, I don't know. That probably matters. I didn't look exactly at the
Yeah,
benchmarks.
yeah, because I know Jules linked me to that paper, and it looked like they were only using a small size that fit in the L3 cache.
Oh,
So if you go to the main memory, that's not gonna work out. And I think just in my compiler, I think it was like something like 5% of the entire runtime is in the kernel zeroing out memory. So it when you're using a lot of memory, it's gonna take just the kernel itself will just take a lot of time because it has to do some work, and then you got to do some work, and then you got to wait on main memory again, like either to write or read. So I had to write a lot of main memory. So yeah,
like if your stuff gets evicted from L3, like that's or if your stuff exceeds the L3 cache, that's only a problem if you're doing lots of random access, right? Like if you're streaming through some kind of file, then like, all of the hardware
well,
prefetch is so pipelined, like doesn't even matter. It can come from the other end of the world, right?
well, if I'm writing 2 gigs or 3 gigs to memory, that's gonna have to hit main memory. So it doesn't matter if it's all sequential because I have to write it to memory because there's so much of it. Like I think the problem was I was generating because my input was several megabytes, and if we go with 50, I think mine was less than 50x. But if we go with 50x, that's a couple of gigs, and you can't fit a couple of gigs in L3.
As
So
But
50x
you
you
but
mean
have
in
this
to
terms of AST or something or what?
um, I think 10 million lines of source code was like a couple hundred megs. I don't actually remember. I
But
can
I
check.
think what was Adrian said, but if you write your iteration in a so predictable pattern, then Adrian, I believe it's correct because the things get so deeply pipelined, so deeply prefetched, because the pattern is so predictable that the cache hierarchy can hide the latency almost as if you're iterating the data is all of the data is all at hand all the time.
No, but that's only if your work is more, it takes as long as the memory, because I go much faster than how long it takes to read and write memory. So memory is just my bottleneck.
Okay.
I'm just doing a check on how many gigs is 10 million lines. In my test, it was only 200 megs, but that's source file. That's not after it goes to the compiler. If it goes to the compiler, I can see it being 5+ gigs, and that's going to take a long time for even the kernel just to zero 5 gigs and give it to me, because
You
because
mean
I know I did a test and it was like
the 5 gigs with all of the AST, analyze it and allocate it?
I think 2 gigs landed me about 200 milliseconds. So yeah, it takes some time.
So you
I
have
have
to
a question.
reduce.
Why is the sorry?
I was just gonna say you have to reduce that 5 gigs. That's your problem.
Well, yeah, 200. If you have 200 megabytes of source file, like you know,
Then yeah, why not memory man?
I was about to ask you, like, why is the kernel zeroing memory at the first place?
because when you ask the kernel for memory, it doesn't want to give you data from other processes. It will just zero it out and then give it to you.
Interesting. I didn't know that.
No, because
So
it's
how
going to
is
have
that
files cached.
how is memmap failing you as a strategy?
It's not reading in the source file. It's taking the source file, generating a parse tree, and then generating IR, and then generating data for the backend, like the actual binary for the backend.
And
So that's like 4 layers of 200 megabytes. That's at that's that's at least a gig, but it's well over a gig.
So you create an arena for that?
Yeah, but like every stage it has to flush the memory, and I also have multi-threads doing it, and yeah, threads don't help so much if your memory saturated.
Yep, that makes sense. So yeah, I mean, to Adrian's point, if you can figure out how to organize the memory so your passes stream, then you should get better cache prediction. But outside of that, you just have to shrink your data structures.
That would be hard. That would be the most engineering work.
Well, yeah.
Well, it's pretty small, but yeah, I'm not exactly sure why my code is very slow, but well, okay, it's 3 million lines and I still say very slow, but the very slow part is specifically parsing the build tree. It's not the other stages. The other stages I do fine at. It's just building a parse tree that's hitting the memory, because I guess it's just
Is
because
it
I
the
have
same?
lookup tables for the like reserved keywords, and
Is it a
I have to do a lot of
recursive descent style of parser? Is it a
pardon?
recursive descent? Is it recursive descent style of parser?
Kind of, but it's just my own thing. Like pretty much everything in my compiler is my own thing.
Of course,
Can
that's
you
fine. But
just ship it all to the GPU and then get back a giant vector of bitmaps? And that will tell
I
you
kind of
what you
wanted to
just
try that.
parsed?
I wanted to try that, but I don't have CUDA.
So-
I don't have an NVIDIA CPU GPU because I'm using Linux, and AMD. I couldn't get its OpenCL and the GPU stuff working on Linux with AMD. So I don't know. I want to try that though. I think the overhead is going to be too high, but I still want to try it.
Your language is Poland, right?
Yeah.
Uh, are your sources open? Is your stuff like updated?
I'm pretty sure somebody's going to fork my code and just annoy me if I open source it. So
I
I'm
see,
just
I
going to
see.
leave it.
we are
And I don't
grilling.
want to deal with Git
grilling
issues.
We
Have
are
you seen?
grilling Clivo continuously to open source, but
The best way to deal with that is just like make it available on some kind of, I don't know, Git server or something, and like just respond to mailing lists, and no one is going to talk to
I
you.
don't want to even respond to anything. I want to get memory safety done and then decide where to go from there.
If you have a mailing list, then no one will talk to you by default. So it's
Okay. Yeah, I should do that then.
my recommendation.
So Adrian, what are you working on?
I'm working on last time I mentioned a bit about like making a language for operating systems. So this is like my current focus. So yeah, I just want to basically take a set of values or ideas and take them to the extreme. So it's exactly what we mentioned in the Discord server. Yeah, so this is probably either going to turn out to be a very niche, very crappy language, or something that maybe some people find valuable. But it's mostly to solve my problems because like when it comes to writing like super high performance code, like in operating system stuff and embedded stuff, like just Rust is not cutting it. And I honestly don't benefit much from the borrow checker and lifetimes, because all memory is all memory is visible directly for me, and I only have one process. I own the entire hardware. The lifetimes are unified. There's like basically one big arena. I don't do much dynamic allocation as well. All my queues are bounded and have concrete addresses. There's like, yeah, it's just a very different use case. So I don't know. And after playing a bit with Zig, I noticed that like the ways I can manipulate things at compile time are really like beneficial. Like, this data structure I mentioned with the enums is just one example, but there are also like many others. And I would
I
like
want to
to,
ask
yeah.
I want to ask more about that, but have you tried writing an operating system with Zig or C? Because I would imagine that they support everything you need for operating system.
I mean, yeah, I tried it with C, and well, C is just not a good language, I think, for this stuff that I'm like intending to do, because it makes, uh, um,
I'm
yeah,
guessing
I
you
don't
like
know.
prefer,
I guess the real question is, what would you do different from what
Oh
is
yeah,
what
that too.
Yeah, like what I would do different from Zig, you mean? Or like because like I think what Zig does over C is already good. Like there are some very good improvements when it comes to like ergonomics and stuff. And then on top of Zig, sorry, I think there are some things like I think the reluctance to just avoid operator overloading is not a good idea. I think I want to have operator overloading in my language.
You
I like
like
Was it the
operator.
guy data?
Yeah, yes, but for arithmetic, that's the thing. Like for arithmetic operators, so plus, minus, division, like there I can see it. For things like binary, like shift left, shift right, I don't see much value in that. And yeah, I don't know. Like there are other things like RAII, this horrible acronym, is actually pretty cool thing, and it gives me a lot of safety. It's not perfect, but like in the type of environment that I have, like my call graph is also very hierarchical and not so recursive and stuff. Like just like RAII is actually
But what
pretty
about
good.
if come up a scenario that you cannot figure out the lifetime of using object?
Well,
I'll
I
just
got
use
an alternate question.
Yeah.
It's what if your operating system was written in Zig, but then you have your favorite language as a higher level language on top of the Zig? Like I don't know what native language you like, but
I mean, yeah, sure. It would probably be a bit clunky. I mean, I think Zig is not hardcore enough, actually. I think just like the
you're
fact
gonna have to say more
actually
about that
Matt,
then.
yeah, like the thing is Matt actually mentioned something really cool last time. So like the problem with like application like languages that are made for writing applications is that linking is a very separate process. But when you're writing something for a specific set of hardware, maybe you want to have linking information as a concept in your language, like determine addresses and layouts and code and boot sequence and hardware capabilities, everything like, I mean, yeah, in the language, maybe at compile time, instead of having a second DSL that describes everything. And yeah, so I think.
So if I understood correctly, the language should support directly some of the operating system concepts invented here. So should lift the concept inside the language so we can operate with the concepts implemented in the operating system directly. Is that correct way to say?
With the concepts, no, like more like the things we have in like the functionality we have in linker scripts, like defining memory regions and like relocating certain pieces of code to some locations. Like that should be exposed in the language, I think.
That was what I was trying to say. The
I see.
the
Sorry.
concepts are inside the language, so you can manipulate them
Yes.
directly.
Right. Yeah. Exactly. That's what I mean. I think also maybe that would be nice to also gear the language semantics, or at least a subset of the language semantics, to be maybe amenable to like heterogeneous systems. Maybe easier compilation to Spear V or OpenCL or FPGAs or something like that. Maybe like having a subset of the language that can work very well with languages like P4 or something. Yeah, and other things like better inline assembly and stuff like that.
So what is your stance about types inside?
Yeah, that's another thing. Like that's also one of my problems with Zig, because I actually the choice to go and write a compiler was not my first choice. I'm generally a pragmatic person and generally reasonable, or at least I was reasonable a few years ago. Now I don't know anymore. But the thing is, I did lots of prototypes for this operating system. I wrote one in Lisp, actually, and in Zig and Rust and C and C++ and Idris and Haskell, all kinds of languages. And I just noticed that with Zig, I have real trouble understanding an API just by going through the code, because of all this very strongly duck-typed style of generics. So they don't have any types of constraints or interfaces, or at least like statically dispatched interfaces. And
you're talking about comp time, right?
Yeah, right.
Okay, yeah.
So basically, a function can accept just a type, and like I had to figure out the constraints on this type, I need to go into the function body and understand how it's called. And so yeah, that makes it really difficult. And the other thing is there's very little encapsulation. So no private members on structs.
Yeah, I have no
which
problem with that.
I like the thing is like if I want to build like data structures that have invariants and have some things that need to stay coherent, then having those not be directly exposed and having constructors that like preserve invariants, I find like quite important because they also tell you how to use an API and how to not to break things. So
I find that when you do stuff like that, you just end up over engineering because a lot of OOP is over engineering.
yeah, but private variables are not necessarily like over engineered. I mean, the thing is, it's just if your language doesn't support like a pure functional programming or has like super strong immutability guarantees, and you need to somehow like control mutation. Otherwise, it can also turn into spaghetti. Like if everything is a free for all. So
I don't hide any of my data for the most part. There's very few classes I have that has private members. Everything else is just a struct.
The problem
And,
I
and
have is
can be mutable. And can it be mutable? Is that correct, Oliver? It's all of the members can be mutable.
Do you mutate the data, Levo?
If it's a class, no, but I only have like literally a dozen classes or less. I have hundreds of structs and less than a dozen of classes.
So do you let mutable data escape at global scale? So not inside a class, not inside a method.
I don't think I have any global classes, but yeah, but I generally no, I don't mutate. If it's a class, I don't mutate the members.
But struct and class are the same thing.
That's what people say.
It's true.
You disagree? If there
The
is
way
no
I use it,
inheritance, how they're
according
the
to
same
the
thing?
standard, maybe they're almost the same, but the way I use it, they're not the same.
I mean, I think the like having private fields has like these invariants have quite a few benefits. I can give you one example, and I don't even think that's like over-engineered encapsulation. Like the best example I have is I have like all kinds of memory mapped hardware. And what I actually would like to have is instead of having a device tree that loads the stuff on runtime, like my device tree is just a struct in the language, and the entire application gets monomorphized, and all the hardware registers are like hard coded, like in the assembly at the end. But like basically, I have a struct called memory region that describes the space in which I can talk to the hardware, and it has a from and a to, like from A to B, and from needs to be smaller than to. If it's not, then certain arithmetics will cause problems and may even like cause exceptions or like really hard to track down bugs.
When
Especially if the
when you said smaller, we are already in the realm of OOP concepts. And smaller, like in the set smaller, it has to be smaller from the things it support. From the B has to be smaller. Is that correct?
right?
Okay,
I mean, yeah,
so
it's
maybe I'm not understanding correctly, but if let's say it's like setting up the memory for like TB like lookup tables or whatever, but instead of saying from and to, why don't you say I want like new memory, and then the function decides the function itself, which you don't control, decides what's the from and to. Like it just figures it out on its own. And you just ask it for what you
I
want.
think he's managing the locations and the sizes. I mean, it's an operating system.
Yeah,
I
but
mean,
shouldn't the kernel decide that instead of like the
He's
thing
writing the
calling the
kernel.
kernel?
usually usually
You
like
can
the
sidestep classes and structs if you have a language that is primitives and lambdas. Then you would be able to encapsulate anything as a mutable or otherwise behind a lambda that isn't going to report the backing stored data if you're using capture.
Mm.
What were you saying, Adrian?
Yeah.
I'm not sure what that means.
Mhm.
So,
could you
all
maybe
right.
like
When you have a lambda and you have some state, and then you're referencing that state inside of a lambda, then you do something else and you pass that lambda somewhere. Um, now you have a need to capture the surrounding state. But the lambda is not going to tell you what that state, is, what it's capturing. It's just going to accept parameters. So if you're looking for encapsulation to use or to mutate a thing, um, you would be able to put it in a capture without going too detailed into vtables and classes and structs. Um, you could use primitives, and just like C with lambda would be good enough to do what you're saying. Gain private variable members.
I can take a look at it. Yeah. I think
Goes
I kind
to
of get
the
it,
old,
but I need to.
it goes to the old debate whether objects are merely a poor man's closures or whether closures are poor man's object. There are still disagreements on which one is correct.
Yeah, I mean, you can
Why
achieve slices
did-
of the same functionality with each.
Of course, yeah. You can implement one inside the other and the other inside the first one. So it depends how you look at it.
Yeah, if you take a collection of those lambdas, you can call it a vtable.
Of course. Why not?
It just happens to capture this.
That kind of describes the Linux kernel.
Quite.
Yeah. I would like to like I don't know, I have this I wrote a few prototypes of this like operating system, but basically I would like to just avoid any kind of indirection. Like everything is like basically as much as possible is specified at compile time, and like all the addresses are known beforehand. Actually, in order to do that, I'm just compiling a device tree with code generation to my language, and then running that. I wrote such a macro for Rust, and it was not so much fun. But yeah, like in the end, it's kind of cool in some ways, because like lots of the code that I have to like that maybe runs on an interrupt or whatever actually doesn't need to look up where the address of anything is, because everything is already known at compile time. So it can just construct the address directly in the assembly with a few instructions, and then just jump to that address or do something with it. So
I'm
there's
curious if
also
you've looked at Plan 9.
The operating system design.
No, I didn't. Is it? Is it? I guess it's like a bit of a distributed operating. I didn't really look at the how it's actually works.
Okay, so yeah, with Plan 9, the concept of this very small microkernel is that everything is a file handle concept. So, what you have may or may not be pointers and C code underneath, but everything acts like a file. So all your mock modules, etc., are, descriptors of files, stream, IO. And that's how a lot of real-time OSs and small kernels proceed. And it sounds like it has some of those benefits. Your pointers and your bindings are pretty static, but you are able to perform like symbolic linking with different descriptor configurations, stuff like that. So, okay, if you haven't looked at Plan 9, you're not going to have a, sort of a contrast with it to share.
So it sounds, Adrian, like you're basically for configuration of the hardware and operating system, you're basically compiling it down to all fixed everything, right? Yeah. So it's very unplanned line-like in that sense.
Yeah, and also like I think I just want to like explore some designs or like challenges around making this type of stuff composable, because it's really difficult to do, because
that would be notoriously composable, notoriously hard to compose such a low level hardware in encapsulating abstractions that can compose together would be a challenge.
Yeah, I mean, that's why I kind of like this like ML style of modules and module signatures, which are a bit more structural, a bit less like less constrained, but still kind of like fairly give you lots of information and how to figure out how to use something. So I think, I don't know, I would just like to try it, because yeah, I actually I would like to particularly look at rack scale servers and like maybe SOCs or something, and just figure out how to write like generic code that in the end takes the hardware specs as a parameter and then compiles everything down perfectly. Like basically monomorphizes the machine. And
I heard
yeah,
that's
actually
really hard to
that's a
do.
subtle point. If you know all the spec of the hardware, it should be possible to eliminate all of the abstraction you prescribed, because you know the exact details of the machine. It should be possible to compile down, to boil down the abstraction to
yeah,
disappear.
like yeah, exactly. I mean, the thing I would like is that the code that you write does not necessarily need to know all of the hardware details. For instance, you can write generic stuff like a scheduling algorithm can be parameterized by, let's say, number of CPUs, number of like NUMA nodes and sockets, and maybe it can be parameterized by a cache to cache or like a core to core latency map or something like that. And with all this information, you just like maybe think of a very efficient way of laying out messaging queues or something like that. I don't know, like whatever comes to mind. And
How far
like,
into writing an OS have you gone?
uh, uh,
So
good question. I mean,
what concepts did you implement your prototypes?
in my prototypes, I just implemented basic networking drivers that talk to a NIC, and kind of like an executor of tasks, like a task executor that runs async
No, that's pretty.
task. Yeah, that's it. But yeah, I didn't. I actually don't want to touch anything like multi-process stuff and threads. And I would like to avoid I would like to avoid virtual memory, because in this, like in my use case, it doesn't really help so much.
Why? Because so all of the program has to be its own
Kernel.
physical address.
Yeah,
All of the programs has to know its address. You cannot move programs. You cannot interleave them if they use their actual physical address.
yeah. I mean, yeah, right. Like the things I was writing were mostly unikernels, so they wouldn't benefit from virtual memory. And
it reminds me so much of so when before operating systems, everything was basically a fixed address load. So the program, you would boot the computer and it would load the program. So whatever program you were running, you'd put it in and boot the computer, and it would copy it in starting at 0 or whatever the fixed offset was for that computer. And so all your addresses were actually hardwired. So, and that's like pretty much that's how the bin or COM files on x86 work, right? It's up to 64 kilobytes of code, and there's more recent stuff as well, but and it's loaded in the addresses are all fixed. So it's kind of, Adrian, what you're describing. And what an EXE was an ability to provide lots of those with kind of pointers to each other, and they could be loaded anywhere and relocated and so on. So you're kind of, if I understand what you're saying correctly, Adrian, you're saying, I want to go from EXE to bin as opposed to, the other direction. You want to devirtualize everything.
Yeah, for sure.
The important thing of what you just said, Cameron, is that everyone was able to do it.
Meaning,
where most developers were able to do like write a binary that can execute on the machine.
well, yeah, I mean that's all there was.
Yeah.
But there weren't many developers either.
Now people can barely write a program without depending on 100 libraries or 1,000 if you're using npm.
I mean, I also think like it's a bit of a like kind of like a big reduction in complexity to go with this route. I mean, it's not easier. It's
No, it's
pretty
harder.
painful actually. Yeah, but it's definitely harder, but it's definitely a lot simpler because
I actually was going to say the same thing. How on these concepts are on the tangent of deterministic execution. All of the program has to be, so you mentioned no threads, no concurrencies. You want deterministic as possible.
Well, lots of concurrency actually. I would, but just not threads. More like cooperative multitasking, like Amiga style. But I don't know if Amiga is multi-threaded, but yeah.
Yeah. So
not the Amiga I remember.
Yeah, I mean, yeah.
Go ahead.
No, it's just like lots of I don't know. Everyone is building Unix OSs these days, but also lots of the decisions of Unix were like based around the time, as I understand, like where time sharing was the very important, and also virtual memory is like highly motivated by both time sharing and hardware virtualization of clouds. So like and security, of course, and every other thing. So basically, all the things that are not relevant to my use case. So I think that's why I can just throw away all the complexity and maybe just experiment with just some interesting hardware abstraction layers and see what comes out.
Are you writing TCP packets in your network code?
I just implemented UDP. I didn't want to bother with, and also probably I didn't implement it according to the spec. Like what I did was, all my code is horrible. I just wanted to prototype stuff to get it out there. Like
prototype code should be horrible, yeah.
Yeah. So, Allan, we haven't heard much from you. But now the good news is you're going to win because Levo's going to port his parser to an NVIDIA GPU.
Well, yeah, no. So like I'm doing something even worse. I've decided, I said this in the chat, but I'm planning on using a large language model as the parser. So I'll just tell it like, here's, and then like output an AST for me, and then I don't know. I mean, I guess it does require a GPU because it's a big model, so you need lots of work.
But at least it's a model that you can run on a GPU.
That's quite a contrast to it.
So I'll use the small model. Like I won't use like the 60 billion or whatever. I'll just use the 70 billion.
So Adrian, is that quite a contrast to what you're doing?
Slightly, just a bit.
So Allan, how serious are you?
I mean, I've been looking at it. Like I haven't been paying much attention to this session so far, besides the Java part. But I've been looking at like how to set up inference clients and that sort of stuff, and I think it can work. I mean, it's worth trying. Let's put it that way.
So actually, I think it's hilarious, but at the same time, I think it's also inevitable. Yeah. So you may actually be onto something.
What I'm not sure is how fast it will be, because like it needs to be like usable. Like you can't have like 10-minute compile times.
Right, and it shouldn't be like Chat GPT.
Yeah. So
why not?
I mean, we've been throwing around like what is it, 10 million lines of code a second for parsers.
That's just parsing, though.
Well, yeah, no, and the language model, all it's doing is parsing into an AST. So I don't know if I can get a language model that fast, but it's worth. I don't know.
It's an interesting topic.
So,
which model are you using? What type? Sorry.
Oh, well, so like I was thinking, so Facebook, they released this code llama model like just a few days ago. It's it's like trained on all these different kinds of code. And then they had this instruct model that you could write in natural language and then it would output code in, I think, in Python.
So the
So like
question, is would you have reproducibility, or would your outcome on every compile be different?
well, I mean, you fix the random seed in the what is it called? The sequence generation algorithm, and then you get fixed answers. So it's not that. I mean, oh,
Our GPU, like if you run like a machine learning model on a GPU and you fix all that stuff, so is these floating point calculations, are they always deterministic?
pretty much, yeah.
Okay.
It's specified by the standard. I mean, in
Hmm.
most computers, they don't add randomness deliberately to their computations. I've heard there are differences between computers. Like if you run it on Intel and you run it on AMD, it might be different, but I don't think it'll be different enough to make it a different output. We'll see.
So basically, Jamie spent all this time building parsley, right? And all you're having to do is use ChatGPT for your parser.
Yeah, yeah, it's kind of. I mean, it was like that with type systems. I spent all this time reading about type systems, and I was like, no, actually, I don't need any of that. I just need a model check. I mean, what can I say? You work hard on technology, and then you realize it's not good enough, and then you throw it away.
Well, really, you just need to hook the LLM up to Aaron's topic and generate, stubs.
What was Aaron's topic again?
Code generators or templates or macros, right?
Right, macros.
The trade-offs.
Interesting.
I mean, like macros, I have a very different concept of macros. So macros are about parsing an abstract syntax tree and converting it to a value. So like the language model does the abstract syntax tree, and then everything else is sort of the execution semantics. So macros are part of the execution semantics. They aren't like a code generator kind of thing.
Well, I think we're at 2:15, so we should probably call it for the day. But interesting. Can't wait to see the ChatGPT person.
Yeah, no, I mean, like, I get, like, the problem is I feel like people won't take my language seriously just because it uses machine learning. They'll be like, oh, it's a machine learning language. You can type whatever you want. That's not a real programming language. So, but
he who laughs last.
I think if you like Twitch, like if you videos to stream yourself just writing a bit with it, I think that's like pretty convincing. Probably have to speed up the video a bit, but I think that can leave a very big impression on people. Like if you can actually demonstrate that you can get some extensible stuff out there with it. Yeah, because it's a bit different, like because it's very like the benefit comes from kind of the workflow and how you interact with this thing, and whereas with, I don't know, other languages, you can kind of advertise them by just putting some sample code on the home screen. But like, that's
yeah, I don't know. And like I wasn't planning on making my language fast. That was sort of part of the design, was like ignore performance, leave it for later. So we'll see.
But you did have inline assembly as one of your requirements.
Well, no. So see, there's a difference. There's like compile time performance and there's runtime performance. The runtime performance I paid attention to. The compile time performance, I said, Google has like 1 million machines just running builds. They won't notice if they need 10 million. So,
well, on that note, let's wrap it up and see you guys next week.
Yeah, next meet will be the same.
So hopefully Allan will have gotten us those 10 million machines by then.
Or at least a working model of the prototype. Like, I don't know.
All right. Well, have a good weekend, guys.
See you guys.
Bye, guys.